So, section 1.6 deals with unit conversion. I'm hoping that you've got some experience with unit conversion in other classes, but we will be talking about this a little bit. The important thing is that you know how to convert units without a calculator. I know that most modern calculators have built-in unit converters, but there is an important skill to using units and working with units that can actually make life a lot easier and help you understand what's going on. So the primary part of this mini lecture is going to be talking about velocity. And first we need to really distinguish between the concept of speed and velocity. So velocity itself is a vector that's denoted by this little bar symbol over the top, indicating this is in fact a vector. And so that tells you it has how much and which way. It has those two pieces of information encoded within it. How much velocity there is and which way the velocity is. So speed really is the how much part. Speed is the magnitude of the velocity. That's this right here. It's v vector with absolute magnitude sign. That's a magnitude. That's a scalar quantity. The direction of the velocity then is encoded in this unit vector v hat or v caret. So speed is how much, velocity is how much and which way. So we start off with the concept of average velocity, and the average velocity is essentially the rate of change of position, how much our position changes in a given chunk of time. And the nice thing is that since we're dealing with a vector here, the components of the vector are each independent. So the motion in the x direction is independent of the motion of the y direction, independent of the motion of the z direction. So we can do our calculations using just one particular component to figure out what's going on with each part, and then combine those three components to give us the overall vector. So the average velocity is telling us how far your position changes each second. Now the reason it's an average is that we're usually dealing with larger chunks of time, and it's possible that your velocity is actually varying as you're going along. So it's just the average over that particular time interval. Now, one thing you need to watch out for is sometimes we see students who will go ahead and find v is equal to, say, the magnitude of r final minus the magnitude of r initial over delta t. And that turns out to not be the case, because for this particular example right here, for this r final, this r initial, if you go ahead and use this formulation, well, the magnitude of r final is 1, the magnitude of r initial is 1, divided by 1 second minus 0 second comes out to be 0 meters per second. That's clearly not the case. The way we go ahead and actually calculate v is r final, which is 0, 1, 0, minus 1, 0, 0, all over 1 second minus 0 seconds. And we just go through component by component. So 0 minus 1 is minus 1, 1 minus 0 is 1, 0 minus 0 is 0, meters over 1 second. So in this case, our velocity turns out to be minus 1, 1, 0 meters per second. So if you're paying attention, you may notice that my units are wrong here. This should just be units of meters, because velocity should end up with units of meters over seconds. Now, since velocity is telling us the average rate of change of the position, we should be able to use this information to figure out where we're going to be at a later point in time, and that's where this position update equation comes into play. So if you know where you started, you know how far your position changes each chunk of time, and you know how long you're going to be moving, that then will tell you what your final position is. Now again, this is assuming that your velocity is more or less constant. over that time period. Now, one thing I want you to pay attention to is how this equation here is related to the equation that defined average velocity. Remember that the V average equation was defined as delta R over delta T, where delta R is simply the change in, or R final minus R initial, all over delta T. Hopefully you can see that these two equations are very closely connected. Now, in later chapters, when we start dealing with changing velocities, we will make some additions to this equation that will make this a little bit more general. Now, we also need to talk about the issue of instantaneous velocity. And the difference between instantaneous and average velocity is basically the time in between our positions. So here we have delta R changes in position for, say, a long period of time, a little bit shorter period of time, an even shorter period of time. And if we imagine taking the limit as that time interval between our 2 points gets smaller and smaller and smaller, those 2 points get together. Now, hopefully you remember what it means to take delta t going to 0. Delta t going to 0 is going to end up giving us the derivative of position with respect to time, dr dt. And that's going to end up being the tangent right there. And so that tangent line is essentially our instantaneous velocity. So that's where the calculus really comes into play in this course.